This is chapter 4. We're going to be talking about the network layer. These are the principles and practical things we'll be talking about in chapter 4. First, we're going to hit on a lot of the principles that underlie network services, forwarding versus routing. We'll look at how a router works, how routing works, and look at some sort of advanced topics like IPv6. We'll also talk about how these principles are instantiated and implemented to actually do routing in the real internet. First, let's remind ourselves about the network layer and how it compares to the transport layer. Recall that the transport layer is an end-to-end service. The transport layer transmits segments from a sending host to a receiving host over multiple hops. The network layer, though, is a point-to-point kind of protocol, kind of layer, and that means that it's concerned about every connection along that path. The network layer resides on every host in the network, not just the endpoints. So when we have packets that are sent from one endpoint to another, every single host, every router is running the network layer. Now, all those routers in the core of the network are not running the transport layer, but they are running the network layer. So when we send out a packet, it has to be encapsulated, and it's sent over the network layer, and it's decapsulated at the other endpoint. Let's think about the two key functions of the network layer. These are two general things that the network layer does. All right. The first thing is forwarding. Forwarding is moving packets from a router's input to an appropriate output port. This is a local decision. Forwarding just happens in the context of inside one router. Routing, on the other hand, is a global process. It's the process of routing, of moving packets from one source to another destination over multiple different routers and hops. So this is a global thing. This involves more than one router. It involves several decisions, several forwarding. By analogy, we could think of going on a trip. If we're going on a trip, routing is the process of planning the trip from source to destination. If we're going from Tennessee to New York, we're going to have to think about what interstates we're going to take, all the different intersections that we'll go through to get from Tennessee to New York. That is like routing. Forwarding is like getting through a single interchange. So it's going up to one red light and saying, do I take left, right, or go straight? That is forwarding. Routing is a global process. Forwarding is a local process. Routing and forwarding meet in a router. The router has a local forwarding table that's going to examine the header value from some packet to determine where its destination address is. And it's going to look up in this forwarding table that header value and send the packets on the appropriate outgoing link. How does the forwarding table get created? The forwarding table gets created by a routing algorithm. The routing algorithm knows the global processes, the global decisions, and it can then create the local decisions that would support those global goals. So the routing algorithm is going to be used to create the forwarding table in each router. A third important function that some network architectures provide is the idea of a virtual connection. IP doesn't do this, but ATM and other protocols do. Recall that the difference between the network layer and the transport layer. At the transport layer, we are providing logical communication between two processes. At the network layer, we're providing a connection-based service between two hosts. So that connection is only between hosts, not between endpoints. It's point-to-point, not end-to-end. What kind of services does the network layer provide? Well, we can look at this in two ways. What kind of network services does the network layer provide for datagrams and for flows of datagrams? At the datagram level, a network service may provide guaranteed delivery of those datagrams. It'll make sure that the datagrams get through. IP doesn't do this. It may also, even more strictly, guarantee that the delivery happens within some bounded delay. For example, this packet will be delivered in less than 500 milliseconds. That's an example of guaranteed delivery with bounded delay. IP certainly doesn't do this either. Properties of the flow are things like in-order delivery. Are the packets delivered in order? And some network layers, not IP, might guarantee that the packets are delivered in the same order that they were sent. Another property is this guaranteed minimum bandwidth. That means that the network layer will guarantee that some minimum bandwidth, say 500 kilobytes per second, will always be present, and the bandwidth will not go below that. And a third network service that might be provided by a network layer is a bound on jitter. Jitter is the variation in interpacket spacing. It's really this undesired deviation from a true periodic frequency. So we can think about receiving packets 1, 2, 3, 4, 5. That has very low jitter because all the packets arrived with the same spacing. An example of high jitter would be 1, 2, 3, 4, 5. You see how that spacing had much more variability, and that would be more difficult for some applications. Some networks might provide guarantees on the maximum amount of jitter that's possible. This table begins to show you some of the network layer services that are provided by different network protocols. The IP protocol has basically none. Different versions of ATM do provide different levels of these sorts of guarantees.